Good afternoon, students. Today's lesson will be right triangles and trigonometric ratios. So at the end of this video, you must be able to find the length of sides in a right triangle as well as find the measures of angles in a right triangle. So there is a correlation or connection between the trigonometric functions and the right triangle trigonometric ratio that you have studied in geometry. If you um, if you restrict the domain of the trigonometric functions to angle measures from 0 degrees, this one, up to 90 degrees, the values on the trigonometric ratios associated with the angles over right triangles are the following. So this is our coordinate as x and y. The distance from this point to the starting or the point of origin will be represented by r or radius. So if that is the case, the sine theta there will be y over r. And since cosecant theta is the inverse of sine theta, we'll just interchange the position of the numerator in the denominator. Cosine theta is x over r, and we know that secant theta is the inverse of cosine theta. Secant theta therefore is r over x. Tangent theta is y over x, and we know that cotangent theta is the inverse of tangent theta. So cotangent theta will be x over y. So let's apply those trigonometric ratios in solving problem number 1. For a standard possession angle determined by the point 8 and negative 6, what are the values of the 6 trigonometric function? I would strongly suggest that you draw the point which is 8 and negative 6 in a unit circle. So not unit circle but in a Cartesian plane. 8 and negative 6 technically falls in the fourth quadrant. So 2, 4, 6, 8, negative 2, negative 6, negative 8. So this is our 8 and negative 6. So this is 8 and negative 6. And we have to find the distance from 8 negative 6 to the point of origin, which is our r. So distance, this is the first step, from 0, 0, which is the point of origin, and then 8 negative 6. So our x sub 1 there is 0, y sub 1 is 0, x sub 2 is equal to 8, and y sub 2 is equal to negative 6. Recall the distance formula in your geometry classes that the distance formula, which is r in this lesson, is given as x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. And then just plot the given. Your x sub 2 is 8. Your x sub 1 is 0. And then your y sub 2 is negative 6. Your y sub 1 is 0. So this is going to be 64 plus 36, which is equal to the square root of 100, and the square root of 100 is 10. So we can now find the values of the 6 trigonometric function. Let's start with sine theta. We know that sine theta is y over r, and our y there is x is 8, y is negative 6, so it's negative 6 over 10. So our r there is 10. I'm just going to list down the given. Expressed in lowest terms, so our sine theta is negative 3 over 5. And then we can immediately solve for the cosecant theta because that's the inverse of sine theta. So cosecant theta, that is r over y, or this is equivalent to 5 over negative 3. Next is cosine theta, which is x over r. The x value there is 8, and the the r value is 10. In lowest term, this is going to be 4 over 5. And then you can immediately solve for the secant theta, since that is the inverse of cosine theta. So that's r over x, or 5 over 4. And the tangent theta is y over x. Your y is negative 6. Your x is 8. Expressed in lowest term, that's negative 3 over 4. And then since cotangent theta is the inverse of tangent theta, so x over y, that's 4 over negative 3. So we now have the values of the 6 trigonometric function. I want you to try practice exercises and then submit it through Go Formative.